Hi guys, my name is Steven, and on behalf of myself and my location manager Carl, I'd like to welcome you back to my calibration channel. I have over 30 years experience working in facility maintenance operations. 10 of those years I spent carrying a bag as a calibration tech, and I've continued to be interested in calibration practice and theory ever since. One of the things I like about calibration is, on the one hand, it produces something that seems to be very concrete. It's a data point, it's a measurement. But at the same time, there's aspects to the system that produces that measurement that are very much not concrete. One of those aspects is the topic that I want to talk about today, and that's the topic of traceability. My target is other calibrators such as myself, or people that work in the vicinity of a calibration function, such as a mechanic or a quality control or quality assurance person. Now, the next thing I'm going to do is violate one of the fundamental rules of public speaking. I'm going to read you something. This is from the International Vocabulary of Basic and General Terms in Metrology. It says that traceability is defined as the property of the result of a measurement or the value of a standard, whereby it can be related to stated references, usually national or international standards, through an unbroken chain of comparisons, all having stated uncertainties. Now, when I read that, I start seeing problem areas. They start right at the beginning with the word property. How can a measurement have a property? A measurement is something, it's something concrete, it's a piece of data. How can it have a property? Well, not everybody has to have the time or patience or knowledge to understand how that can be. But if your company depends on calibration or traceability, there'd better be somebody in the neighborhood who has the time, the patience, and the knowledge and the responsibility to cover this for your company. In addition, even in that first sentence, I see another problem area towards the end, and that's the word uncertainty. Now, I've only got 5 to 8 minutes to talk about traceability, so we're not getting into uncertainties today. I love this topic, but it's not going to fit into 8 minutes, so stay tuned. So let's tease out some of the properties that traceability does have, and let's do a demo. Now, I said that I carried a bag for 10 years as a tech. One of the fundamental things you learn as a tech is turn on the meter first. So here we go. First thing I notice about my meter is it's got a calibration sticker on it. What's that mean? It just means that this meter has been sent to a lab, probably a certified lab, that used standards to measure its performance. And then they produced a document, a certificate that comes back to me along with the meter to tell me how it did. Now, I'll tell you right now, the standards that the lab used to produce that certificate are not traceable. However, the measurements that they made with those standards are traceable. Okay, so what that implies is, in turn, this meter itself is not traceable. But under some circumstances, the measurements it produces can be traceable. So let's try and do a measurement. I'm going to measure the DC value of this DC source that happens to be duct taped to the bookcase. Okay, here we go. There we go, I got a measurement. And like a good tech, I'm going to turn the thing off to save the batteries. Now, what is it about what I just did that's traceable? I already told you that the standards back in the lab that certified this thing are not in themselves traceable. This meter is not traceable, but in some cases, the readings that I just took could be traceable. So what's this all about? It's about measurement risk and capability. If all I care about in this measurement is a half a volt or a volt uncertainty, then we know that this meter is fully capable of producing the measurement we need. We know from past practice as technicians that this is true. If we have any doubts, we can go to the Fluke website or read the Fluke literature that comes with this meter that tells us what it can do and what it can't do. The cert that came back from the lab also provides the same information. However, let's consider another case. Suppose the uncertainties of this measurement we need are down in the picovolts. We know now this meter could never produce a measurement that good. We know from past practice. We know from the fluke literature. If we call a fluke and say, hey, can we make this measurement at an uncertainty of 5 or 10 picovolts, fluke is going to tell you, no, you cannot possibly make that measurement, and there's nothing you can do to this meter that will make it capable. Also, the search would show us the same thing. So while we're talking about what this meter can and can't do, let's talk about things like that. Certain buildings in Gaithersburg, Maryland, or Boulder, Colorado, that have NIST on a sign in the front of them are not traceable. The people that work in those facilities are not traceable. Even the standards at NIST, the standards that they maintain or manufacture, are not in themselves traceable. The measurements they make are traceable. That's the big difference. It's the measurements made by these devices that are traceable and are connected to the unbroken chain that I talked about earlier. So, to sum up, traceability helps us make decisions about process capability. Is our measurement process capable of making the measurement that we need to make to stay in business? I enjoyed making this video. I hope you enjoyed watching it. I have to say it cleared up some stuff for me that I was a little bit more vague on than I really should be if I want to call myself a calibrator. So I hope you enjoyed it. I hope you'll stick around for other videos that I intend to make on other topics that I find of interest. In the meantime, on behalf of my caterer, Carl, I'd like to thank you for your time and say good afternoon.